Hello viewers, today's video is about electronic component learning. So whenever we have to work about electronic and its components, we have to estimate some measurement of particular components. Here it is a BLDC fan or inverter fan. Why does it called BLDC? Since it also have a magnetic and 3 core wires, similar like a BLDC motor. Its input is a 2 power wire, as here it is indicated. These wires are the live and neutral wires, and these 2 wire, red and black, and the third wire is here outside, here in the outside. These wires are one wire is signal wire and the 2 wires are power and neutral wires. So it does not have, this fan does not have, an inverter fan does not have a capacitor. It has an electronic circuit. Let me show you its electronic circuit after this disassembling, since whenever we turn it on, it does not on. Something here in this circuit is faulty. We will try to diagnose what is fault here in this circuit. Let me quickly dismantle from this assembly and show you its circuit. I have removed it from fan. It's an electronic circuit. When we open its cover, we will find its PCB board, and there are 3 wires. This is phase wire, always connect to the motor red side, red wire. This black wire connect to the black, and this is called signal pin. It's also known as speed or signal pin. So it's similar work like an ESC electronics speed controller of BLDC motor. Here these are the 2 input wires. One is known as for a neutral, and second used for live wire. So these are also known as UVW. Their code are known as UVW, like this way. So now here I will try to help you learn about how to diagnose fault of the electronic components by using multimeter. Here I have removed the cover, and I will let me explain you the basics component or a basic component. Here you can see the input wires are going here into the board that are supplying 220 volt. So this first component, this one, is a fuse. So first of all we have to check fuse, as physically it is good in condition. So what is the fault here? Why does this PCB board is not working? This second component, NTC, is a negative temperature coefficient, mean it is a thermistor. So thermistor is work like a resistor, so it loses its resistance whenever the temperature is increase or decrease. There are 2 type of the thermistor, PTC or NTC. So both are work as a resistor. So this is a transformer. Next is a bridge rectifier. It is a bridge rectifier that is used to transform AC to DC. Next, it is capacitor used for filtration. All capacitors are used for filtrations as well. So we will try to assess that either in the fault in the capacitors or IGBTs or crystal that is used for the frequency stabilizations, or wherever in the fault is. We will try to diagnose either is the fault of transformer or fuse or thermistor or bridge rectifier or capacitor, whatever. We will try to diagnose all the faults by using a multimeter. Okay, as I explained you, there are different components are installed. So we have to assess, start testing from main supply portions. So this is the input portion where we provide 220 voltage AC, and this is the output portion where we get also 220 voltage, but also there is a signal wire. This is a signal pin. So one is positive, second negative, and then the green color is a signal wire, similar like a BLDC motor. So here we adjust the our multimeter in a diode mode, and we see the connectivity like this way. So our buzzer or the multimeter will indicate the continuity of the so first of all we will test the fuse. If fuse is okay, then we will listen this kind of beep. So the first indication is indicate that its fuse has been blown. Second, we will test its NTC negative thermistor. If it is okay, then it will give some kind of beep. We can rotate this one in outside here as this way, so it's easy to assess this one. So we know that this is the input portion and this is the fuse point. So if the fuse is okay, then they must give a like this the connectivity sound, like a buzzer sound will become. Since fuse has blown, so there is no sound, so we have to replace this fuse, and this is the point of the NTC, so this is okay. So it is indicating some kind of resistance as we will connect here. So we see there is some kind of resistance and sounds. Then we have to check this also, it's bridge rectifier. If the bridge is working, then we have to see that there must be a sound from when negative to positive, we will say, like a forward bias. Diode always conduct in forward bias, and it does not conduct when it is in reverse bias. Reverse bias means diode work in it resists the flow of the current in reverse bias. So see, oh, so this is also indicating that its bridge rectifier is completely blown. There is no any kind of sound. Let me show you a healthy bridge. It will be, this is its bridge rectifier, which is this bridge rectifier is completely has been blown due to the short circuit here, or due to the short in this circuit. Also we need to test its capacitors. So electrolytic capacitors are installed here. We can recheck. Yeah, these are the electrolytic capacitors. So electrolytic capacitor also conduct from negative to positive. So see, 272 volts when it is yeah. So if when to check the capacitors, we have to connect negative probes to this negative sign side and positive probe to the positive side. So when we will conduct this way or check this one, then its voltage must have to be increased, as in the multimeter it is continuously increasing. See once again, if the capacitor is healthy, it will continuously increase its voltage. If the capacitor is not completely healthy, then it will never increase its voltage. As this capacitor indicating it's swelled out and it's also blown, so it's burst due to its weak electrodes, or we can say its internal structure is weak, due to which it has been blown. So when it is blown, definitely it will never indicate its negative polarity is here. So in this side we will connect negative probe, and in this this is the positive probe point and this is the negative point. But on the same behavior. This is not giving any kind of charge storing or any kind of indications here in on the multimeter. So this indicates that this capacitor is completely blown. So finally we will change capacitor, and we will also change its bridge rectifier. We will also change its fuse. Before to change, let me show you a healthy fuse, a healthy components, and it will help you to learn more. So see here, I have extracted all the damaged component. This was damaged. This is a capacitor with the value of 450 volt, 4.7 microfarad. I will replace this one with 450 volt with the little higher value of the microfarads, so that it have a ability to store little extra charge. There are different kind of bridges I have extracted from different PCB boards. I will help you. I will indicate you which one is okay, and I also have a fuse. I will tell you which one is better and not. So to check the fuse and other component, we will readjust the multimeter at diode mode. So as I have indicated you how to test this bridge rectifier. So we will connect the multimeter negative probe to the negative side of the bridge rectifier. Bridge rectifier have two sides of the indication. One is positive, second is negative. So we will first connect the from negative, and we will connect one by one. There must not be a connectivity sound like this way. This sound is not, this sound indicates that there is something fault. So see, this indicates this is shorted. It is not a bridged, but it is short. This is short, this is short. So each line is short. So we will check it from the positive to the negative. If we check positive to the negative, it is again indicating short. So this indicates this bridge rectifier is faulty. This is another bridge rectifier is also have to be assessed that is it okay or not. We will connect the probe at one terminal. All terminals are the short. So if we connect from negative to the positive, again short. So this is also a short bridge rectifier. So if we will continuously replace the probe, and we will connect positive with a positive, and see everywhere is a short. So this bridge rectifier is also faulty. So we'll see this one. So as we will see this bridge rectifier, is it okay or not? So we'll connect negative terminal, its negative point, with a positive probe as here, see, and we will connect the second. There is no sound but a higher value. So from outsider, from this to this will definitely have to be indicate a very high value. So this indicates this bridge rectifier is okay, and comparatively there must be lower values here and here. Yes, it is okay. So this bridge rectifier is fine. So if I connect positive with a positive terminal here, it have to be indicate 1. Yes, yes, yes. So this indicates there is no flow of the current here. It completely resists. Since a diode only permit a flow of current from in forward bias, not a reverse bias. So reverse bias, it behave like a closed door. As it is a closed door, there is no indication, there is no beep, there is no sound. But in a forward bias, it is indicating some kind of resistance. This is the resistance value, higher values. So here comparatively slow values and low values. Okay, so this bridge rectifier is okay. Now we'll check the fuse. If fuse is burned, there must not be beep sound. Yeah, it is burned. So if fuse is okay, this fuse is new one. so there it must have to indicate some sound. That's this one. This indicates that fuse only allow a single path like this way. Current start from here and leave from this terminal. So fuse have only this function. So this indicates that this fuse can be replaced, this capacitor can be replaced, and this bridge rectifier. So these three components we required, and we will replace this one with our this BLDC motor driver. So this is basically a fan driver. We will replace this one. So first we have to refine our soldering iron. So if there is some kind of kinks, we have to remove that kinks so that it will be clean and neat bit. So we have to clean the bit, as we can use our screwdriver. I also have pulled out all the components that were necessary to remove at least. So I have removed fuse, I have removed capacitor, I also have removed bridge rectifier. So I will replace these three components here, and let's see what happened. So okay, although the video is going to little longer, but it's necessary to explain you. So to replace the component, we will put suitable and proper component at a proper port here, and since already soldered and there is some kind of blockage in the holes, so we will have to little press it here, and we will put hot iron here. It will, yes, it has opened. Okay, so now we will replace with the soldering wire. Like this way. So we have fixed our fuse. Now we will replace this bridge rectifier. So before to replace this bridge rectifier, be careful about its polarity, as in on the PCB board it is indicated positive here and negative on the other side. So we have to replace it like this way, otherwise it will a big fault. So finally I have replaced all the component, and I will resolder this one. This is the capacitor. Okay. And extra leg must have to be removed. So I have finally installed the capacitor, and since it's an electrolytic capacitor, so polarity, when you are installing, polarity must have to be considered. Positive must have to be connected with the positive side of something else. Since here is a bridge, so bridge have this side are positive, so we will connect the positive of the electrolytic also in this side, and this side is a negative, so we will connect the negative of the capacitor here. So basically function of this capacitor is filtrations of the ripples in the outside of this bridge rectifier. So this is a fuse which we have installed here, and rest of the component are also installed. Basically, so if the fuse is exactly working, So fuse function is only this one. From here it will take AC, and at this end it will give AC outside. So this component will be will be a short here. So here it is outside. So if the bridge is working or not, so we'll see. So we'll see here the bridge is working or not. So there must not be a reverse bias function, but in the forward bias it must have to be indicate something. High resistance here and here. Okay, it's fine. Yes, since this is a positive side, so capacitor is also indicating 562 volts, and 562 value of the charge that it is stored here, or it was some current in the outside of the circuit. Okay, so finally this is a way to repair or diagnose the problem of any electronic component. So today's video was about electronic component, introduction to different faults, and diagnosizations of different fault, installation of different components. I am sure that it is fine now. Finally, I have reinstalled this one into its box, and I will also install it into fan and see if either fan is working or not. So finally it's completed. I will connect input wires through AC and the output wire to the winding of the motor, and let's see the function of the fan, either is work or not. Okay, as usually I have reinstalled. Let me explain you something here. This wire is indicated with as AC 1 neutral or live. N or L mean neutral live. This wire also indicated some code here, neutral, AC 1 and neutral. So neutral, N mean indicate neutral. So double N indicate, since it has a bridge, full rectified bridge, not a half wave rectified bridge. So since when we have a full wave rectified bridge, then there is no specification of we have to be only connect here of a phase, and there is a neutral. So if neutral is replaced here and phase is replaced here, then it's fine. There is no problem in the circuitry. So these three wires are connected like such a way that here three wires are going into the motor. Phase must have to be connected phase with the red wire. So board circuit red wire must have to be connected with the red, but here this is a yellow wire and the one is a black wire. Black is connected with the green, and green is yellow wire is connected with the black wire. So this is a way to connect this circuitry. And now let me turn it on and see its response. As we turn its button on, and we see the fan is working okay, fine.